All right, buckle up. Here we go. Here's a long problem that might be at the end of our test. This would be one of the tough problems that we do in our class. This is the population of a city that's experiencing exponential growth. And so what I want you to understand is when you see this, when it says it's undergoing exponential growth, that means we're using the formula A equals PE to the RT. The city is continuously growing, okay? Just like our bank account problems. And here's what we're going to do. Okay, this is a two-part problem. It says 20,000 people lived in the city in 2000. And by 2010, the population had grown to 28,000. So it went up 8,000 people. If the city continues to grow at the same rate, how many people will live in the city by 2020? So that's our problem. Is how many people are going to live in 2020? The ignorant person, the person that doesn't read this and say exponential growth is going to just simply do this. They're going to say, and by the way, if this is an end-of-course exam problem, or if this is multiple choice, I'm totally putting this answer here because it seems too easy, and it is, okay? Somebody's going to say it went up 8,000 people in 10 years, so it's going to go up another 8,000. It's going to be at 36,000 people. 36,000 is not the correct answer. Okay, that would be a linear growth model. That means it continues to grow the same rate, the same number of people come every single year. Exponential growth, if I was to graph it, would look something like this. Here's the population of 20,000, and it's going to go and it's going to increase like this, okay? So maybe it's going to go up 8,000 from here to here, but from here to here, it's going to go up more than 8,000. So we're going to have more than 36,000 people whenever it gets done, okay? Just understand that. It's not just as simple as adding 8,000 twice. So here's what we're going to do, okay? We're going to look at 2 years that we do know data for. We know that in 2000, and if we went to 2010, we went from 20,000 people to 28,000 people, right? So we're going to pick up a couple of points that we do know. With that in mind, I'm going to treat it like this. If I look at the population here, the final population is 28,000. We can use that as our A value. And the starting population here, my principal value, is 20,000, okay? Final equals starting. I'm going to multiply times E. I do not know how quickly they're growing, so R is something I'm not going to be able to solve for, but I do know that year-wise, 10 years have passed, so I'm going to put in 10 for the time. Seems out of focus. Hold on a second. All right, there we go, okay? So we're going to treat it like a bank account problem. Instead of banks, instead of money, we're talking about people, right? I started with 20,000, I ended with 28, and 10 years went by. And what we're going to try to do here is our first step is we're going to solve for the growth rate. It's like the interest rate of a bank account problem, right? We got to find out how quickly it's growing first. So that's our first part. Number one, solve for R. Okay, if you want to write a little note to yourself, part one of this problem is to solve for R. My first step, as always, you've heard me say it in the previous 4 videos, is to divide by the principal. Divide it out. 28,000 divided by 20,000, put that in your calculator. It equals exactly 1.4. These two go away. If that was a messy decimal, I'm going to keep all of the decimals in my calculator. But it's not. It's just strictly, it's 1.4. Equals E to the R times 10. Now the way that I get rid of E, both times, that I've done this twice before in today's videos, I got to take the natural log of both sides. ln and e cancel each other out. So that goes away, and I'm left with r times 10 on the right. The left-hand side is the natural log of 1.4, which I'm going to put in my calculator here in a second. Now, after I do that, that tells me r times 10, so to get rid of the 10, I divide both sides by 10. The interest rate is going to be the natural log of 1.4, whatever that is, divided by 10. I'm not going to round this value at all. Natural log of 1.4 is this, and I divide it by 10, it's 0.0336. 0.0336. I'm going to put dot, dot, dot. That means it's a decimal that keeps on going. I'm going to use this. I do not want to round it at all. I'm going to leave it just stored on my calculator for now. By the way, that's 3.36%, right? So it's growing at 3.36% per year, okay? If that was a bank account problem, that'd be our interest rate, okay? Now, let's go and apply it. It says if it continues to grow at 3.36% at that same rate, how many people are going to live in the city by 2020? And so we can look at it as part two. We're going to find the final population. That means in our formula, we're going to solve this time for A, okay? The nice thing is now we know a starting amount and we know the interest rate. That's the big deal. So we can look at it 2 ways. We can start at 2000 and go to 2020. If that happens, I'm going to use a time value of 20 years. I'm going to use a starting population of 20,000, and my final population is what I'm trying to solve for. Or I can look at it as 2010 to 2020. And if that happens, then I'm going to use a time value of 10 years, but I'm going to use a different starting population because the population in 2010 was actually 28,000. The final population is what I'm going to go for, right? So that's what I'm interested in. I can use either one of these and I'm going to get the same value out, okay? So pick one. Let's just do this one, okay, for the sake of simplicity. I started in 20,000. Ready? My final amount, that's what I want to know. So what's the population? The initial population is 20,000 times E raised to the, and now I know it's the 0.0336, so on and so forth. That number is unrounded, times the number of years that went by, and in this case we're saying from 2000 to 2020, 20 years went by. So let's figure out then, all I have to do is plug this in my calculator. Ready? Here's the unrounded value, the 0.0036. I'm going to multiply by 20. That gives me the thing in the exponent, right? So there's that times 20. Now I need to take e raised to that power. So I'm going to say second. I'm going to use the ln button, e raised to the power of, and then I'm going to use second, and I'm going to hit the negative sign, a and s. So it says e to the power of the previous answer. So I don't have to type all that out again. That gives me, wow, that's cool, 1.96, exactly. All right, so now I've gotten everything here. E raised to that power is 1.96 exactly, so I'm going to multiply by 20,000. I get 39,200 people. A is 39,200 people. Well, once again, if you remember at the very beginning of the video, I said the person that doesn't realize it just doesn't go up by 8,000s every time is going to say 36,000 is the answer. We actually have more because as time goes by, the population goes up quicker. Okay, so hopefully that makes sense. Just real quick, just to show you what would happen if I would have chosen the second situation, you would have said the final amount is equal to the starting amount of 28,000 times e to the 0.0336 times, and in this time, your time, only 10 years have passed, okay? If you would have used this formula, you would have gotten 39,200 exactly the same. So just know that you can use either one. Hopefully that makes sense. That's a long problem, right? Look how much stuff you have to do there. You have to solve for the interest rate first, the growth rate first, 0.03336, and you're not going to round that value. And then you have to go plug that new value for R into another problem to figure out what the final amount is going to be. Your starting point is arbitrary. Do you want to use the 2000 population or 2010 population? You're going to get the same answer in the end. So there you go. There's all 5 problems that we're going to have to deal with. Don't expect to see this except for the last problem on the test.